This session here in Romans 4 is Hot Knives Through Butter, bypassing automated analysis systems with Jong Bu and Abhishek Singh.
Thanks everyone for joining this session. Appreciate it. I don't know how many of you know Barnaby Jack. So right now in another room, there's a memorial event going on to memorize him. And, so I just want to take this time and basically express my feelings about him. He and I were co-workers. He's my ex-co-worker in McAfee Labs, and he's a true inspiration to me and to many of us. He will be missed for sure. Okay, so let's, I'll hand it over to Abhishek to begin this session.
Thank you, John. In 2011, we were seeing close to 80,000 samples per day. And in 2013, currently we are seeing close to 200,000 samples per day. It is quite obvious that we won't have to end up analyzing all the 200,000 samples. We have like a generic and the heuristic-based signatures which have capability of catching unknown samples. And besides heuristic and generic signatures, many times we see new variant of a known family of malware. So if we have an advanced classification algorithm, we can easily catch a new variant of a known family of malware. However, still amount of samples what we are seeing per day is huge. Now, in order to be able to say if the files what we are seeing is good or bad, one approach can be to use a human analyst. On an average, the human analyst will take like close to 30 to 45 minutes of research, and after which he can easily say that the file what he's seeing is good or bad. And with the exponential growth of the unknown sample, this is not scalable. The other approach, which is currently being used by AV industry, is to use a file-based sandbox. A typical architecture of a file-based sandbox is as shown in the figure. It has traps at a various level. It has application trap, it has trap at a kernel, it has a trap at a CPU. It takes the file as an input. It executes these files. These files make calls to different functions. And when these calls are being made, these calls are being captured by these traps. And a sandbox monitoring unit will convert these calls into the behavior. Once we have the behavior of the file, then an analyst will be able to say if the file is a good file or a bad file. If the file is malicious, signatures can be generated and those can be deployed. Now the question comes, the amount of samples what we are seeing per day, is it really being captured by a file-based sandbox? The answer is no. All the samples what we are seeing, not all the samples what we are seeing per day can easily be caught by a file-based sandbox. And this is the whole presentation is all about. We have broadly classified the evasion techniques into 4 parts. In the first part, we have evasion techniques which make use of human interaction. In the second part, we have evasion techniques which make use of configuration issues. Then we talk about the classic techniques. These classic techniques, they have been discussed in information security space, but we still see a considerable amount of samples which still make use of these techniques. And last but not the least, we have environment-specific evasion techniques. File-based sandbox, they emulate a physical system which lack human interaction. And this fact has been used to develop evasion technique. This is a code from Trojan UpClicker, which was observed by us in December 2012. It makes a call to the function set Windows hook EX, And in that function, it passes the parameter 0EH. By passing this parameter, it hooks to the mouse activity, after which the code has a switch case function call. Only when the left mouse button is clicked up, it unhooks from mouse activity and makes a call to the malicious code. Besides hooking to mouse, Windows executable has also been seen making use of message box and message box EX API to create dialog boxes, and only when these dialog boxes are clicked, malicious activity takes place. The human interaction is not limited to Windows executable. It is also been seen in PDF files. As shown in the screen, this is the code of malicious JavaScript. It makes use of App Alert API to pop up a dialog box, and only when the dialog box is clicked, malicious activity takes place. The goal of the sandbox is to mimic the environment provided by an actual computer, and in order to be able to do so, it has a predefined set of parameters. Again, with the amount of samples what we are seeing per day, the file-based sandbox can give only a certain amount of time to a particular file. Now, to bypass the configuration issues, one of the things what we have seen is like extended sleep call. If the sample is sleeping for an extended time, then it can refrain itself from capturing of its behavior by the sandbox during its monitoring activity. This is the code from a Trojan NAP. A Trojan NAP is the revived version of Kalios botnet, which was claimed to be taken down. As shown in the code, it makes a use of Sleep EX API with a 10-minute timeout. It also has to be seen that alterable value in this code is set to false. So the code will sleep whatsoever may happen. Besides using Sleep EX API, undocumented APIs like anti-delay execute can also be used to have extended sleep calls. Again, the sleep calls, they are not confined to Windows executable. It has also been seen in case of JavaScript inside a PDF file. As shown in the screen, it makes use of app set timeout API with a 16-minute timeout, and only after the timeout, it makes a call to the malicious function. The time trigger or the time bombs, these are a very specific sample. This particular sample was being used to wipe out drives of computers in Korea. The whole execution step in this case can be broadly divided into two parts. As a part of the first step, it makes use of the API get a local time to get the current time. If the current time is less than the detonation time, then a sample makes a call to the sleep function with 60 seconds timeout. It then again checks if the current time is equivalent to the detonation time. The moment current time becomes equivalent to the detonation time, sample will execute. It is quite obvious that if a time-triggered sample are being dropped inside a file-based sandbox before their detonation time, it won't execute, and it can easily prevent itself from capturing of its behavior. This is one of the very sophisticated piece of a code which was observed in push 2. As shown in my previous slide, the file-based sandbox, they have to capture all the behavior. Microsoft provides kernel routine PSP set create process notify routine to allow security software to be able to monitor the process creation and deletion of the files. As such, there is no publicly disclosed method for a third-party application to be able to register for these notifications. In case of a push to, what it did was that it very specifically checked for the build number. When it got the build number, it checked for the very specific opcodes, a move EDI and push EDI. As shown in the code of Windows, after a move EDI and just before push EDI, we have the address of the PSP set create process notify routine. So once it has been able to locate that address, it directly jumps to that address and it will set all the callbacks to null. So now if any new process is getting created or deleted, there won't be any notification. Besides these techniques, we have also observed a considerable amount of classical techniques. As such, these techniques have been discussed multiple times, so we don't plan to go too deep into these techniques. Many times, the file-based sandbox are very particular and specific to a vendor. And if they are very specific to a vendor, there are certain processes and files or keys which are specific to that vendor. And as shown in this code, that it very specifically checks for Joey's box server. And these files are very specific to Joey's sandbox. In order to create a sandbox, we can use a VMware virtual PC, virtual box, and all these applications, they have very specific processes and services which are specific to them. So one of the very commonly used technique is to enumerate all the processes and services in a sandbox, and once it has been, the code is being able to locate the processes and services which is very specific to a VirtualBox, VMware, or a virtual PC. It will know that it is executing inside VMware, a virtual PC, and a virtual box, and it can stop itself. In this case, like it very specifically check for if a VM a mouse.sys is there. If it is being able to locate VM mouse.sys, then it is obvious that it is executing inside a VMware and it can stop its execution. Okay, so we have a demo. As I mentioned earlier, the Trojan up clicker, it got activated only when the left mouse button is clicked. I think it got it's
it works
working
now.
now, right? Yeah.
Okay. Yeah, very good. Thank you.
Sorry about that. As shown in this demo, when we execute the code malware.exe, absolutely nothing happens, which is obviously because the code is not executing inside a debugger. When we execute the code inside a debugger, as we can see that it starts executing. The code is running, but there is no activity. Only when we click the left mouse button, which is slightly tough to show, we can see the activity of the code. It starts. So basically, the whole code is dependent upon the mouse activity, and a Trojan up clicker, it injects itself in the SVC host, and after injection, it opens the backdoor, and we can see that it starts doing the activity.
All right, thanks. So just to recap, right? Altogether, we classify all of these evasion techniques into 4 categories, right? So Abhishek went through this human interaction, right, and also the basically configuration, right, and also the classic evasion techniques. The next part I'm talking about is more of like on the environment part. So basically, each of the malware will require a specific environment to run, right? So it could be a malicious, exploit code, right? It will basically target on a particular specific version of the vulnerable application or platform, right? But on the other side, file-based sandbox, it's kind of like having just one environment over there, right? It has its own specific environment. When these 2 environments do not match, we got problems. So the first very common evasion here is basically version checks, right? So exploit, when they try to attack, they want to make sure they're running, the target system is running the expected vulnerable application that they are looking for, right? So this is actually a case study of a flash 0-day happened in February 7th. We basically, I think, this attack itself happened in 5th, and it got published and then, publicly, announced on 7th. So what it's doing here is actually to check for the versions of basically the Adobe, Flash player, and make sure, it will run only on the targeted versions. So actually, let me run a survey here. So how many of you have this, Flash player on your system? Many, I hope. And how many of you keep them updated all the time? How many just don't care? Right. So for those of you who always keep your system updated, congratulations, you are vulnerable to this exploit. So basically, but on the other side, if you never upgrade, you'll be vulnerable to all of the, kind of legacy exploits, right? So as you can see here, the exploit itself is very picky. They look for a particular environment. If in the file-based sandbox, this system do not have this, particular versions listed here, you will never be able to trigger anything, right? So the same technique has been used, in a lot of attacks. The next example is actually something a little bit different. So we've seen some, malicious Flash files over there, right? So this time, basically, they actually append this malicious content, as you can clearly see from this link here. At the end of the, basically after the footer area. So basically, this is the area that, will never be interpreted by the Flash player or Windows viewer, right? So in this particular case, though, there's another piece of the malware that will read this information and execute it, right? So in this particular case, if the sandbox has only one file, because how sandbox works is basically you throw in an object, right? It will whatever run for you, and then give you the diff, right? What you have is only one file object. If you miss another part of this attack, you will not see any malicious activity. Another similar case here is actually a GIF file, right? So basically, GIF file has header field, right? Message, content field, and also additional metadata field, and also the footers, right? After the footer field, 3B is the tag showing it is the end of GIF data stream. And basically, all of the content after that is pretty much considered as a common area, right? Again, no, basically common application here, like the Windows viewer, will load this area and basically execute this code. So if you, again, has only one GF file over here, the file-based sandbox cannot interpret anything. And here comes another more complicated case. So when we look at this case, it's actually very, very, very impressive, I would say. I think the threat actor behind this one is very creative and cheerful, I would say. So you will see why I say that. So basically, first of all, there's this malicious payload over there, right? And what we observe as the behavior of this payload is basically it keep going to this harmless, Chinese blog site, right? And when we go to the blog site, you see what I see here. It seems like there are just some harmless links over there, right? And it's even not clickable if you look at it, right? It has this common thing like HXXP instead of HTTP. And it turned out to be actually this is a link for that basically payload to download this object. And you may wonder, what is this object, right? And here we go. It is a Japanese, cartoon figure. Nothing special, you see what I see here, right? So then, looking into this, cartoon hero picture, right? So after the end of image tag, basically you will see an unknown padding field of 471 bytes. It's complete bar garbage over here, if you can see, right? Then this payload actually load this JPEG file, go to this unknown padding field, right? It will extract it and decrypt. Finally, that 471 bytes will turn into an INI file here, right? When you look at this file, it makes a lot more sense to you, right? To me, right? So as you can see here, it gives you all of these, commands and what are these additional files for you to download, right? So I guess now you will have a pretty good understanding of how this whole thing works, right? Basically, this payload will go to the site, get a JPEG file, which is actually the CNC command from the master, right? It will execute this command and basically post another JPEG file up, which is also embedding all of this in this unknown padding field. Okay, and that communication keep going on. So what you'll see in your network is basically a whole bunch of these files. These are all the real JPEG exchanges over there. Very cheerful threat actor, I would say, right? But so as you can see here, right, if this file-based sandbox, it is in a kind of like a true sandbox mode. Basically, it cannot talk out. That's the common configuration of the file-based sandbox, right? Basically, you will not allow it to go out to anywhere, right? Because you don't really want to run a malware in your sandbox and it launch some DOS attacks to White House, and next day you got FBI knocking your door. Hey, can we talk? So basically, in order to actually trigger all of these malicious activities, as you can see, a pure file-based sandbox is very limited, right? And this actually poses a fundamental issue here, which is, for attacks like this, they're stateful, right? You will have to really understand the whole life cycle of a particular, attack, instead of just looking at one file in an isolated environment, right? It is limited, right? So then basically we went ahead and run all of these malicious kind of like examples over there against some of the very common or popular online malware analysis systems, okay? And each of them leverage sandbox technology, right? As you can see, none of them can be, none of them can be kind of like 100% bulletproof here, but some of them are basically resistant to some of the evasions, right? And that's the state of art. That's the reality now. That's what you have. So basically, we categorize each of these evasions and run this test. And hopefully, we will basically people can use this as a framework, a comparison framework, to help you better understand basically the sandboxes that you're using, right? How effective they are, and also to help you better understand their limitations, right? So that when you are doing your research, you don't get fooled by this malware with advanced evasion techniques. So clearly, as we can see, right, sandboxes, file-based sandboxes are definitely useful for researchers, right? It's a great diff tool. Basically, you throw something in, it gives you all of the changes that this object ever made to the system. It can help you to basically reduce your research time. But on the other side, it is not a classification tool yet, right? By classification, I mean, can it give you a result, right? Instead of giving you thousands of lines of activities, just tell me if it is malicious or not, right? So there's a long way to go. But I'm pretty sure there are a lot of efforts, both commercial and also open source, basically improving all of this, right? On the other side, though, I think, as you can see, for all of the evasions, right, some of them has been handled already. That basically means, these communities are definitely improving their system, and that's great. So we'd like to call for basic action that basically really they need to have this, hardening and basically evasion resistant in mind, right? And also, sometimes it is very difficult to actually, counter this evasion, right? So let's say, for example, there's a version check. How do you counter that, right? You will probably have to have multiple different versions, right? Try them one by one, right? If you don't have the version, you don't have the version. It will not run, right? And sometimes, basically, there's a sleep call. It's going to sleep so long. But please let us know, right? So in your report, in the report of this, sandbox result, let us know all of the suspicious possible evasion activities, at least, right? So it will be great if they can counter, but if you cannot, please also put this information out, like if there are extremely long sleep call, right? If you terminate the process run because of sleep call, right? So things like that give us more help, right? And also, I think I want to really kind of call out that this evasion things, they are definitely not kind of like fiction, definitely not. So each of these Kilios, push-to and push-ive, each of them used a evasion technique that Abhishek just demoed previously, right? And most of the zero-day attacks we've seen in the recent several months, they all have this version check and the environmental kind of like evasions over there, right? And as you can see, overall, maybe like 1 year ago, these sandbox vendors figure out some of the evasion here. They put the code in and fix them, right? And this year there are more, right? And they are different. So each of this category, the reason why we want to put them in a category is because, they're actually, what we present here is actually just some demo cases, right? There are almost like infinite possibility for the evasions to basically evolve. Let's say sleep calls, right? You can do sleep call, and I can take some actions to basically shortcut it, right? But then, okay, if you're shortcutting, the malware writers are going to do this, I'm going to sleep short time frame, short time period, but 5,000 times. How do you shortcut that, right? And even more, they can basically just say, okay, so I'm going to have a routine that's just doing complete garbage work, right? I'm not sleeping. I'm doing something, right? Like some of the corporate coworkers, right? So, there are endless kind of possibilities over there. So each of them, we wanna describe these categories, right? And then encourage people to continue to think along these lines, right? And next is basically, if you remember all of these environmental evasions over there, right? As you can clearly see, stateful is basically the middle name of all of the advanced attacks, right? Isolated sandbox system is definitely not the answer to address this very complicated advanced malware threat. The modern malware threat landscape has been evolved into this phase that, I don't know how many of you were in the 2004 DEF CON when this LSD group first announced the first, Microsoft MSRPC vulnerability, right? And at that time, nobody dared to basically, open up their Windows system. Within just with one packet, your machine can get compromised. There's no stateful thing at all, right? If you look at things, kind of like, it's all go all the way back to, let's say, NIMDA, right? It's just one line of web request, and the server is compromised, right? But now it's more sophisticated. You will see this malicious file coming in, decoyed as a very innocent file. If you receive a file, pretend to be your boss, pretend to be from your boss, and say promotion letter, are you going to open it or not? Right? And everything can be spoofed, as everybody knows. So after this, there will be malware payload download, and all of the callback activities, like there's a cartoon, figures over there, it's all stateful. So my point here is that understanding the context is very important for us to basically fully decipher this whole attack lifecycle. So I think, multi-flow and multi-vector analysis, on top of this, file-based sandbox basic technologies. So we'd like to basically make one point very clear, right? File-based sandbox is just a tool, right? It's like a knife or a gun. Basically, it is as good as the system that use it, or as good as the person who use it. It is a tool. So in order to really address this, advanced malware issue, you need a system that can correlate all of the stateful behaviors of this attack. And I'm not saying that's the silver bullet, but it is a never-ending battle. So with that, I'll conclude and open for questions. Thanks.